Have you ever looked at a string like A, B, and wondered if I could change just one character, what's the longest block of identical letters I could create? At first glance, it feels like a dynamic programming problem, but surprisingly, this is actually a sliding window problem that runs in O and time. Let us understand it from absolute scratch. We are given a string consisting of uppercase letters and an integer k. We may replace at most k characters with an uppercase letter. Our goal is to find the longest substring that can be converted into one repeating character. For example, if s equals AB and k equals 2, we can convert both a's into b and it becomes this. So answer is 4. Now let's take another example. Our s equals this and k is equal to 1. So if we transform the b into a, then we can get a b b a. So the substring with all characters identical will be a and answer equals 4. Let's dive deeper. Let's imagine we are looking at some window A B. So we are looking at this window. Now ask a question. Can this entire window become the same letter? Suppose we want everything to become A. How many replacements are required? There are 3 A's and 2 B's. Only the B's needs replacements. So the replacement needed are 2. So suppose we want everything to become A. Then the question is how many replacements are required? Currently, there are 3 A's and 2 B's. Only the B's needs replacement. So replacement needed are 2. Only B's need needs replacement. So replacement needed are 2. Notice something important. We never replace the majority characters. We only replace all the remaining characters. This gives us our first key idea. So for every window, replacement needed equals window size minus frequency of most common character. So for example, if my window is AB, this is my window. So window size equals 5 and most frequent character is A and frequency of the most frequent character equals 3. Therefore, replacement needed is equal to 2. So it is exactly correct. This single formula is the heart of the problem. Now suppose k equals 1. If a window requires 0 replacements, that is valid. And if it requires 1 replacement, that is still valid. For k equal to 1. If it requires 2 replacement, now it becomes invalid. So whenever window size minus max frequency is greater than k, our window is too large. We must shrink it. And that is how we get intuition of sliding window. Let us dry run this example. We will maintain left-right frequency map, maximum frequency and answer. Or let us first write the pseudo code and then we can write the code and after that we can do dry. So let's write the algorithm first. For every character increase its frequency. For every character increase its frequency and update the maximum frequency. Now if window size minus max frequency exceeds k, shrink from the left and update the maximum answer. So I think we need to do a while loop here. And we need to repeat until the string ends. So let us now write the Python code. Let's initialize the frequency of all characters. This set will contain frequency of all the different characters. Let us initialize left, max freq and answer. Now let us start the loop. Then we check, we increase the frequency of the element we are on. So it says that frequency of the element, the character at right index. That should be frequency dot get. If it is in the set, then give me the its frequency. Else give me 0 value if it is not in the set and increase that by 1. Then max frequency. In case you have any difficulty in understanding this line, please mention it in comments. Then max frequency equals max of max frequency and the frequency of S, right? Then we run a while loop where we check the size minus max frequency is greater than k or not. If it is, we decrease the frequency of the leftmost atom and increase the left by 1. Finally, after coming out of while loop, we update our answer. Answer is the maximum length of the subarray. So it will be max of answer and right minus left plus 1. Finally return the answer. So in the algorithm, we update the answer here. So from the left and update answer. Now let us dry run this for one example so that you can understand it better. Let's take a very simple example. So first our left equals 0, right equals 0, answer equals 0, and the set frequency equals empty. So we are looping through right. So at right equals 0, we update our frequency of S right. So my frequency set will become, what is my S0? A. So it will have A, first element as A, and its frequency will be 1. Then what do? I increase the max max freq is also there. Max freq will become frequency of SI comma max, that is max of 0 comma 1, that is equal to 1. Then I will see while this condition is true or not. Right minus left plus 1 minus max freq. So that is equal to 0 minus 0 plus 1, 1 minus 1, that is 0. That is less than k. So I will not go inside while loop, I will simply update the answer. So answer equals max of answer comma right minus left plus 1, that is equal to 1. And then I will go to at right equals 1. My freq will become A 2, and max freq will become max of max freq, that is 1 comma 2. It becomes 2. So frequency was right. Now right minus left plus 1 minus max freq is greater than greater than k, is less than equal to k. So I'll update the answer. So my answer will become 2. Now right will increase once again at right equals 2. I have B. So Frig will have a different set. A will have the value of 2 and B will have the value of 1. Max Frig will be equal to 2 only. And my right minus left plus 1 minus max Frig will be equal to 2. And this is now greater than k. So my while loop will start. My left will become, first of all, Frig s left will be minus equal to 1. So Frig will become, just a second. So Frig will become A1 and B1, and my left will increase and left will become equal to 1. Now I'll check again the same condition. This time it is equal to 1 and that is less than equal to k. So it will exit the while loop. Now answer will become max of 2 comma right minus left, 2 minus 1 plus 1, 2 comma 2. So it will remain the same as equal to 2. Now at right equal to 3, Frig equals, this thing is A. So Frig will become A2 and B1, and max Frig will become max of max Frig and frequency of S right. So that will remain as 2. Then this value right minus left plus 1. My left is equal to 1 and right equal to 2. So it will become 2 minus 2, that is 0. Okay, so actually I think it was right equal to 1 and left equal to 0. So 1 minus 0 plus 1. So 2 minus max Frig was 2. So 2 minus 2 was equal to 0. So we did a mistake here. It will be 0. And that is still less than equal to k. So this step is correct. Now here right minus left plus 1. That is equal to 2 minus left is equal to 0. So 2 minus 0 plus 1, 3. 3 minus 2 is equal to 1. So 1 is actually less than equal to k. So this thing won't take place. We will simply say answer equal to max of the previous answer 2 and right minus left plus 1. 2 minus 0 plus 1, 3. So answer will become 3. Now at right equal to 3, I will have A2 and B1 and max equal to 2. At right equal 3, A will become 3. Now 3 minus 0 plus 1 is 4. 4 minus 2 is equal to 2. Now here is a problem that 2 is greater than k. So my trick will change. It will become A2 and B1, and my left will become equal to 1. Then right minus left plus 1 minus max trick. So that will again be updated. This time it will become 1. 1 that is less than equal to k. So answer will become max of 3 comma right minus left plus 1, 3. So that will remain as 3. Now at right equals 4, my frequency will become so 0, 1, 2, 3, 4. It is B. So A will have 2 and B will become 2. Now max freq is equal to the max of max freq and frequency was right. So that will remain as 2. Now again the formula right means left plus 1 minus max freq. So this time right equal to 4, left equal to 2, left equal to 1. So it becomes 4 minus 2, that is 2, that is greater than 2. So my freq will change. Will become A2 and B will become 1 and my left will become equal to 2. Now I will check again, and this time it is a 1 that is less than equal to k. My answer will remain is equal to c. So this like this the loop will continue. Okay, we did a mistake here at right equal to 3. Our max frequency will change to become 3 because our S3 is this A and its frequency is now 3. So we look at the formula of max frequency, so it is maximum max frequency and frequency of S right. So it will become 3. So in this case, right minus left plus 1 minus max freq will become equal to 1 and that is less than equal to k. So all of this will not happen. Now answer would become max of 3 comma right minus left plus 1, 4. So it will become 4 now. Now here it will become A3 and B2. Max freq will become 3. Right minus left plus 1 minus max freq will be equal to 2 again because our left was 0. Right is 3 plus 1, 4. 4 minus 3 that is 1. 4 plus 1, 5, 5 minus 3, that is 2. So it will be 2 and 2 is greater than k. So frequency will decrease, it will become A2 and B1. I hope you got the idea about what we are doing. Rest you can complete on your own. If you want to me to dive deep into this, we can do that. But the logic is very obvious. So let us now run the code and see if our test case is pass or not. Let us submit it. Okay, all the test cases have passed. Now let us see its time complexity. So here you can see that we are running a single loop and each element can enter like at most once, at most twice. It enters the windows once and character leaves the window once, not twice. So maybe we are processing it double or 2 times, but that is not a big deal. It is a normal integer multiple of n. So time complexity will be of order n, and space complexity is a frequency map, stores only upper case letters. So it is on, and the space will be a O1 because only 26 characters are there, 26 characters. So this map will have 26 different entries. This set will have 26 different entries. So that is O1. Now let us discuss the common mistakes. First mistake is trying every replacement separately. That becomes exponential. Second mistake is replacement recomputing the maximum frequency after every shrink. This makes the solution slower. And next is shrinking when less than equal to k. So that is a wrong formula. We need to shrink only when it is greater than k, not greater than equal to k, because exactly k replacements are allowed. Then thinking we need to know which characters we are converting to. So we actually don't need to know, the frequency formula automatically handles it. Let us summarize. The key insight is replace every character except the most frequent one. That leads to the formula replacement needed equals window size minus maximum frequency. If replacements exceed k, shrink the window, otherwise expand it. Using this simple sliding window technique, we solve the problem in O(n) time. If this explanation helped you understand sliding window a little better, don't forget to like the video, subscribe for more DSA and AI content, and I will see you in the next one.